In an effort to provide training materials to reach the majority of DoD suppliers, this video provides step-by-step details on using SolidWorks CAM to create automated CAM programs with the pre-taught machining strategies. If your team uses Siemens platforms, do check out our other 2 videos on automated CAM programming using Siemens NX.
Hi, I'm Nasir Mannan, Principal Engineer here at the Connecticut Center for Advanced Technology. Today, let's take a look at how we can leverage model-based definition to automatically generate a CNC program. We're going to be using SolidWorks CAM to accomplish this task. Normally, we would take a look at a 2D blueprint and make a conscious decision on how we're going to produce that part. We would take a look at the number of features, the size of the part, and then if we take a look at the tolerance requirement that each of these features have to be made to, we would be making a decision on the strategy that we use. Well, what if we can teach our software how to make those decisions for us? What if, using model-based definition, a file format that contains not only the nominal geometry, but also embedded within it the requirements for each of the features, leveraging model-based definition in this way can really help us save a ton of time. If the software has the ability to make those decisions for us that we would normally take manually, imagine a part with hundreds of features, and the software automatically generates the correct CNC program based off of the strategies that we taught it. This not only becomes a time saver, but it's also a way to capture that knowledge. Let's now look at a file that has a number of different prismatic features on it. We're going to go through the process of setting up SolidWorks CAM to be able to read the PMI and appropriately generate a CAM path based off of the requirements that the features have to be made to. Here we have a part open in SolidWorks, and we can see that there are a number of features such as holes, we have pockets, we have slots, we have chamfers, we have fillet, edge blends, facing operations, and attached to those features we have the requirements. So as an example, if we take a look at this pocket width requirement, we can see that this one has a tolerance of a requirement to be made to 1 inch, but the tolerance being a plus 2,000 minus 3,000 tolerance. So this is on what we call the undersize strategy. And then we have the other pocket on the other side that has a width tolerance of 1 inch plus 3,000 minus 1,000. So we would call this an oversized strategy requirement to be able to produce that part. And for the holes themselves, we have requirements for the diameter as well as the depth. We also have requirements for example, the depth of this slot to be produced to plus 3,000 minus 0. And what we're going to do is we're going to teach SolidWorks what strategies to use to produce these features reading the PMI attached to the manufacturable feature. Next, we're going to set up our machine in SolidWorks CAM. Behind me here at CCAT's Advanced Technology Center, we have a DMG LaserTech 65. This machine happens to be a metal additive hybrid machine with high precision 5-axis machining capabilities. This particular part, as I'm seeing here on the screen, only really requires 3-axis machining. So we're going to set up our environment and our machine to reflect that. So the first thing that we're going to want to do is come into SolidWorks CAM onto the tab here, and we're going to want to define our machine. So if we go into defining our machine, we're going to want to do a mill inch. It is a medium duty machine, so we're going to select medium duty, and we'll go over to our tool crib. I have a tool crib already defined for the DMG machine, so I'm going to select that. Otherwise, there are some out-of-the-box tool cribs available through SolidWorks CAM. But we'll see how we can add tools to this tool crib, and then we can save that out with the additional tools. For our post processor, our machine does use a Siemens Cinumeric 840D SL control. So for our post, we want to choose the Siemens 840D post. This comes out of the box with SolidWorks CAM. And if we go over to now our rotary axis, again, we're not going to set this up because we're not going to use the rotary axis or the tilt axis, so we're going to keep this off. From here, we can click on OK. And next, we want to go over to our stock manager to set up our stock material. If we right-click on the tree, go to Edit Definition. What we want to do is set up a stock material that will have a little bit of extra material on all sides. There was originally a sketch in the SolidWorks model that we're going to base the stock material off of. There are several types of stock that you can set up. In this case, you can easily set up with a bounding box. Here you would specify your additional offsets from your X, Y, and Z axis. You can also go to a predefined bounding box. In our case, we want to do an extruded sketch. So here in our feature tree, if we scroll down, we have a defined sketch that is offset from the top of the part by a certain amount. And we're going to want to do an extrude based off of an offset to a face. So we're going to select this bottom face here, and we're going to leave that at 0 so that our bounding box goes from an offset from the top right to the bottom of the part. In the 3D graphics area here, we can see an orange outline preview of that stock material. That looks good from here. We can accept that. The material that we want to choose, in this case, this part is going to be made out of aluminum 6061 T6. We have a number of different materials available to us. In this case, I'm just simply selecting what we have available through our material library that comes with SolidWorks CAM. I can go ahead and accept that to set my stock. And next, we want to make sure that we have our coordinate system defined. So if we right-click on our coordinate system and edit definition, I want to be able to touch off on the back left top of the stock material. So what we had set up in our model was a predefined coordinate system, which we named coordinate system 1. And we had it oriented in such a way where Z is pointing up, X is pointing to the right, and Y is pointing away from us, which is the coordinate system for our machine here. So we've chosen to go with coordinate system 1, and you can see there that we have a preview of that in the 3D graphics area. So we can click on the checkbox here. At this point, that's all that's required to set up our machine. Next, let's head over to setting up our tool crib. Over on the top tabs here, if we navigate over to our SolidWorks CAM tool tree, you can see that we have a DMG tool crib already defined, but we want to be able to add some additional tools to this tool crib. Let's add a 1/8 inch flat end mill. If we right click on the DMG tool crib and we go and add a new tool, we can add tool from library, or we can define a new tool. In this case, we're just going to grab a tool from the tool library. We want the tool type to be a flat end mill, and we can do we can filter this so that we just filter up to 1/8 of an inch. In this case, we will go with an effective cut length of 1/2 inch, which should be sufficient for our part. So we'll click on OK, and that will add our 1/8 inch flat end mill to our tool crib. What we can do from here, if we want to save the new tool that we just added to our DMG tool crib,